These are your notes on transformations. We're going to be going over reflections, rotations, and dilations. So just make sure that you're taking notes in your spiral. First off, things you need to remember. Coordinates are written X, Y, alphabetically. There are 4 quadrants on a coordinate plane. Whenever you were in 7th grade, they may have explained it to you as drawing a C for coordinate plane, and it'll go around identifying the quadrants that way. The C starts in quadrant 1, goes to quadrant 2, and then quadrant 3, and then quadrant 4. So these are going to be our 4 quadrants. It's important that you remember these 2 things. Coordinates are written X, Y, and then the quadrants go in the form of a C on the coordinate plane. This is your x-axis running along left to right, and then your y-axis runs up and down, north and south. You in 6th grade, you probably learned the phrase, you run before you fly. Whatever works, stick with that. Translations are also known as slides. So you're moving a figure left or right, or up or down. To move a figure left or right, you add or subtract to the x-coordinate, because it's on the x-axis running left and right. So we have this image here on our coordinate plane, image W, X, Y, Z. So let's first identify the original coordinates. W is at 2, 2. X is at 3, 4. Y is at 4, 2. And then Z is at 3, 1. Now we're going to be moving this image 3 spaces to the left. So whenever you move left, you subtract. Whenever you move right, you add. It's just like on the number line. So we're going to take 3 away from our X. 2 minus 3 is -1. And leave the Y alone because you didn't shift it up or down. You only moved it to the left. 3 minus 3, because we're going 3 places to the left, is 0. Leave the Y alone because you're not moving up or down. 4 minus 3 is 1. Leave the Y alone. You're not moving up or down. 3 minus 3 is 0. So these are our new coordinates. With these coordinates, we can go ahead and graph our image shifted 3 places to the left. To move a figure up or down, you add or subtract to the Y coordinate. So for this image, we're going to be shifting up 1. So take our Y, that's the one on the right, add 1 because we're going up. If you were going down, you would subtract. 2 plus 1 is 3. Leave the X alone here. Just add 1 to the Y because we're shifting up 1. Add 1 to the Y. Same here. Adding 1 to the Y. And now that we have our coordinates, we can graph our image shifted 1 up. Reflections have also been called flips. That's an easy way to remember it. They are mirror images. You may be asked to reflect over a specific axis, X or Y, like flip over the X-axis or flip over the Y-axis, or over a designated line. Flip over X equals 3, or flip over Y equals 2, which you will be practicing in class. So here's my original image. First, I need my coordinates. A is at 2, 3, B is at 3, 3, C is at 4, 1, and D is at 2, 1. So I'm going to be reflecting over the x-axis for this. Whenever you reflect over the x-axis, you are changing the y, because whenever you flip over the x, you're going down. So you're actually moving up or down. You're flipping over this line, but you're moving up or down. So the change is not in the x-coordinate, the change is in the y-coordinate. So if I were to flip this, that would make this 3 a -3, because I'm moving over the x, so that means it's changing the y. If I change the b and flip it, it's going to go from the 3 to the -3 on the y. And then the c, it's going to go from 1 to -1, because we're flipping over the x, so we change the y. To -1 for vertices D. When I draw my image, it looks like this. So as you can see, it is reflected over the x-axis by changing the y's. Now we're going to be reflecting over the y-axis. So before you reflected over the x, so you were changing the y. Now we're going to be reflecting over the y, so we're going to change our x. We're going to be moving along that x-axis. So my 2 becomes -2, because it's going to be over here now. We got to reflect over the y. My x becomes negative here, my x becomes negative there, and my x becomes negative there. And now I'm going to just I'm going to graph my coordinates, and you can see that it has been reflected over the y-axis by changing the x coordinate. Dilations. This is where you blow something up or you reduce it. So enlarging or reducing. We're going to take this rectangle right here, and we are going to enlarge it and reduce it. So I'm going to show you both. It's very simple. Scale factor is by how much you're going to enlarge it or reduce it by. So if I wanted to blow something up 3 times itself, then my scale factor would be 3. If I wanted to draw a picture half that size that we were looking at, then my scale factor would be half. So here it explains if your scale factor is 1 or more, the image is going to be bigger. If the scale factor is less than 1, like half of it, that would be a smaller image. It's important to remember. So first, I found my coordinates. So we're going to be using a scale factor of 2. I know this looks like -2. That's a typo. It says -2. But in order to blow something up, my scale factor is 2, so it's going to get larger. You have to change the x and the y. So if you look at this image that I'm holding up and I enlarge it, I am not only moving along the y, I'm also moving along the x. So I'm going to have to change both coordinates. So I'm going to multiply the x by 2 and the y by 2. 1 times 2 is 2, 2 times 2 is 4, so my new coordinate is 2, 4. 2 times 2 is 4, 2 times 2 is 4, 2 times 2 is 4, 0 times 2 is 0, 1 times 2 is 2, and 0 times 2 is 0. And now I'll graph this new image, and I have enlarged the image twice its size. Now we're going to reduce the image, so I'm going to use a scale factor of half, which means I'm going to be multiplying my x by half and my y by half. Half of 1 is half, or 0.5. Half of 2 is 1. Half of 2 is 1, half of 2 is 1, half of 2 is 1, half of nothing is nothing, half of 1 is 0.5, or half. Half of 0 is 0. You also think of it as half times 1, which is 0.5. Half times 0, well, anything times 0 is just 0, so that's how come these are zeros, in case you were wondering. Chart it, and you have reduced the image by half.